By every rule of science, Io should be a frozen wasteland, colder and farther from the sun than Mars. Yet its power does not come from sunlight. Instead, a hidden and relentless energy source drives Io's chaos, rewriting everything we thought we understood about planetary geology. Historically, we looked at places like Earth's moon, Mercury, or distant moons like Callisto and assumed that distance from the sun meant dormancy. Io shatters that assumption.
This is no ordinary moon. Io is a living paradox. Its crust torn apart and rebuilt by heat so fierce, it outshines the wildest volcanoes on Earth or anywhere else we know. Mountains melt and collapse, plains glow like metal in a forge, and the moon's heart seems to beat with volcanic fury, never resting. Imagine if the entire surface of Hawaii was constantly erupting, and then multiply that by 10. That is the level of chaos you would witness on Io, a world where stability is a foreign concept.
What if the wildest volcanoes in the solar system do not erupt on Earth, or even on any planet at all, but on a moon that seems impossible? A world that by all logic should be frozen, silent, and dead, yet is anything but. Imagine a place so volatile and unpredictable that its surface is constantly being torn apart and rebuilt. A world where fire, not ice, writes the story of its existence. This is not science fiction. This is Io, the most tortured and volcanically active moon orbiting Jupiter. And what happens on Io is more than an astronomical oddity. It is a challenge to everything we thought we knew about how worlds live, die, and maybe even nurture life.
Meet Io, the strangest of Jupiter's moons, a cosmic rebel that refuses to play by the rules. Orbiting hundreds of millions of miles from the sun, Io should be a dead, icy rock, locked in perpetual darkness and cold, like so many moons scattered throughout the solar system. Instead, it is alive with unending violence. Rivers of lava cut across its battered surface, and plumes of molten rock blast hundreds of kilometers high, escaping into the empty blackness of space. Imagine standing on Io's surface, the ground trembling beneath your feet, the sky occasionally lit by fountains of glowing sulfur, and the horizon colored in yellows, reds, and greens that make no sense to the human eye.
Ignore this story, and you risk clinging to outdated ideas about where worlds can be active and where the seeds of life might take root. In the late 20th century, before the Voyager probes reached Jupiter, the notion of an erupting moon was fantasy. The reality turned out to be stranger than fiction.
Recent discoveries have only deepened the puzzle. Io's brutal heat and constant eruptions do not just defy the textbooks. They force us to rethink what moons can be, where energy can hide, and what kinds of places might nurture life in the universe. For decades, the standard model of solar system evolution placed moons like Io safely in the category of dead rocks. Now, Io stands as a warning that our categories are much too simple.
To solve Io's mystery, we must look beyond the sunlight and dig into the forces that reshape entire worlds. The search for answers begins in the shadows of Jupiter, where science meets the unexpected, and where the rules of planetary physics are bent nearly to the breaking point. Meet Io, the innermost of Jupiter's large moons. It orbits its giant planet at nearly 400 million miles from Earth, about 6 times the distance from the Sun to Mars. Io is similar in size to our own moon, measuring about 2,260 miles across, but that is where any similarity ends. Io is no pale, silent companion. It races around Jupiter, locked in a fierce gravitational struggle, not just with its planet, but also with 2 sibling moons, Europa and Ganymede. Their combined gravitational pull stretches and compresses Io in a relentless cycle, turning its orbit into a cosmic tug-of-war. Picture a moon that defies every expectation, a world scarred, glowing with wild colors, and searing with heat that seems unimaginable for a place so far from the sun. This is no gentle, frozen ball drifting in darkness. Instead, it pulses with violence, alive in ways that challenge everything we thought we knew. When the Voyager spacecraft first sent back images of Io in 1979, scientists were shocked. Here was a moon that looked more like a fever dream than a planetary body, its surface painted in surreal hues. This is no gentle tug. Io's orbit is wrenched and squeezed, the entire moon flexing like a battered cosmic stress ball. These titanic forces heat its interior, driving turmoil and chaos deep beneath the surface. It is as if the universe itself has set Io on a treadmill of destruction and renewal, never letting it rest. How could a distant, icy moon become a furnace of endless fire? The answer is where Io starts to rewrite the rules of planetary science. The secret lies not in sunlight, but in the powerful and invisible grip of gravity. No other moon in our solar system is brutalized like this. While most moons remain cold and still, Io is a world of fire and transformation, its heart twisted by invisible hands, as if the universe itself is determined to tear it apart. You could compare Io's fate to that of an object placed between the jaws of a hydraulic press, except here, the press is gravity itself, and the cycle never ends. Assuming that moons are just silent, frozen rocks leaves us blind to places like Io, worlds that break every rule we thought unbreakable. In the 19th century, astronomers mapped the surfaces of the Moon and Mars, seeing ancient craters and lava plains, and concluded that geological activity faded with time. Io is nature's rebuttal. Io's secrets are locked within its constant internal torment, an engine of energy that powers the most extreme volcanism in the solar system. What scientists have uncovered there could upend our understanding of energy, geology, and the very nature of worlds. The implications ripple far beyond Jupiter, challenging our search for life and energy elsewhere. While volcanoes on Earth slowly build mountains, Io's volcanoes do the opposite. They rip the surface apart and paint it in impossible colors. Imagine volcanoes that do not just erupt, but also erase and redraw the landscape every few years. This is Io's reality.
Io's fury does not come from radioactive decay or shifting tectonic plates. Instead, it is fueled by tidal heating, Jupiter's immense gravity, joined by the push and pull of Io's sibling moons, stretches and squeezes this small world as if kneading dough. This relentless cosmic flexing creates friction so intense that it melts rock deep underground, forming vast magma chambers.
The outcome? Io is the most volcanically active place in the solar system, boasting more eruptions than anywhere else we know. There are hundreds of active volcanoes, each one a window into the moon's violent heart. Some eruptions are so powerful, they hurl jets of molten rock and gas hundreds of kilometers into space, distances Earth's volcanoes could never reach. For comparison, the most powerful eruption ever recorded on Earth, the eruption of Mount Tambora in 1815, sent ash 30 miles into the atmosphere. On Io, plumes can soar over 200 miles high, easily escaping the moon's gravity. Yet Io's volcanoes are not like anything familiar. Instead of building up mountains, they tear open enormous collapsed pits called paterae, spread vast lava flows, and send rivers of molten rock racing across the surface at breakneck speeds. Some of these lavas are hotter than any found on Earth, sometimes exceeding 1,300 degrees Celsius, echoes from our planet's own fiery beginnings. Imagine a lava flow so hot it would vaporize steel upon contact, and you begin to appreciate the energy unleashed on Io. Io's surface tells the story of this relentless chaos. Its chemistry is utterly alien. Sulfur dominates here in all its forms. Volcanoes erupt clouds of elemental sulfur, sulfur dioxide, and other strange gases. Once they settle, these chemicals stain the surface in vivid yellows, deep reds, eerie greens, and blinding whites. Colors so bright and strange, it seems more like a fever dream than a planetary landscape. Historical explorers such as Captain Cook described the sulfur vents of New Zealand's White Island as otherworldly,
But even these pale in comparison to Io's palette.
Those patches that look like snow, they are not water, but frost made of sulfur dioxide. When Io slips into the shadow of Jupiter, the temperature plunges within minutes, causing its thin atmosphere to freeze and fall out of the sky. Volcanic plumes soar hundreds of kilometers, then return as chemical snow, endlessly reshaping the land. Imagine if, every night on Earth, the atmosphere condensed and fell as frozen rain, only to sublimate back into gas by morning. That is the bizarre cycle on Io. All the while, Jupiter's fierce radiation bombards Io, sparking exotic chemical reactions and making the moon's surface a living laboratory. No eruption is ever quite the same. The landscape never settles. It is a world in constant turmoil, a place where geology and chemistry are locked in a never-ending battle. The surface is so young that few impact craters survive. Volcanoes erase them within a few million years, a blink of an eye in planetary time. If we fail to grasp the true source of Io's energy, we lose a blueprint for how worlds can remain alive, even in the farthest, coldest reaches of space. Tidal heating reveals that the wild dance of gravity alone can spark planetary transformation, hinting at new possibilities far beyond our homeworld. In the 19th century, the only known heat sources were sunlight and radioactive decay. Io's example forces us to add a third, tidal friction, a source that may lurk in countless hidden worlds. What if Io's interior is even stranger than its tortured surface? A hidden labyrinth where hundreds of volcanic engines churn, reshaping the moon each and every night. For years, scientists imagined a single, vast magma ocean beneath the crust, but recent data paints a more complicated picture. But Io's drama is not limited to its surface. Its eruptions reach far beyond, shaping everything from Jupiter's magnetic field to the edge of the planet's space environment. Io's volcanoes spew sulfur and oxygen atoms into space, creating a vast, invisible torus, a donut-shaped ring of charged particles that whips around Jupiter at great speed. This plasma torus glows in ultraviolet and influences the planet's powerful auroras, much brighter than any seen on Earth. For many years, scientists pictured a single, globe-spanning ocean of magma lurking under Io's crust. But NASA's Juno spacecraft has crushed that theory. Instead, new gravity data shows something far stranger. Io holds a scattered archipelago of magma chambers, each separated by thick walls of solid rock. There is no unified ocean, just a patchwork of molten pockets, each stirring to its own rhythm. This means eruptions can occur independently, making the moon's geology less predictable and more volatile than anyone had guessed. Let's dive beneath those battered, sulfur-painted plains and meet the true monsters driving this chaos. Io's mountains are nothing like Earth's. Towering, sharp peaks, like the colossal Steeple Mountain, which climbs higher than Everest, reveal a world where the crust is squeezed and shattered by relentless internal pressure. These mountains are born in bursts, not by steady tectonic drift, but by abrupt, violent folding and collapse. The landscape rips apart and rebuilds itself under forces no earthly summit could endure. Imagine a mountain range forming and collapsing in a human lifetime, each peak a testament to the moon's ceaseless energy. Juno's most recent flybys have shown us this mayhem up close. The probe has witnessed lava lakes overturning as we watch, sending fountains of molten rock arcing skyward. Massive plumes punch through the crust, blasting sulfur and stone hundreds of kilometers high. Entire regions morph in days. Dormant volcanoes awaken, old landmarks vanish under waves of ash and blazing new lava fields. This is dynamic geology unlike anything on Earth, where landscapes usually change over millennia, not nights. This revelation changes everything. With dozens of isolated magma reservoirs, every region of Io can erupt on its own unpredictable schedule. Picture the moon as a planetary pressure cooker, not with one burner, but with dozens firing at random intervals. Some places simmer in silence for years, then suddenly disgorge rivers of lava.
Others seethe constantly, painting the landscape anew every single day and night. This is not unlike the eruption cycles seen at Yellowstone on Earth, where multiple magma chambers create a complex and dangerous system. But on Io, the scale is global.
Io is not just a geological oddity. It is a living laboratory for forces that may shape countless other worlds. The more we learn, the more we realize how much remains hidden beneath the surface. Every new mission reveals complexity, new volcanoes, unexpected chemistry, and mysteries that force us to rethink the basics of planetary science. If we ignore these lessons, we risk overlooking the wild diversity of worlds beyond our own. We could miss signs of energy, habitability, or even life on planets that break the rules, a mistake that could blind us to the universe's true potential. In the 19th century, the discovery of hydrothermal vents on Earth's ocean floor upended our understanding of where life could exist. Io reminds us that our imaginations must stretch even further.
Io's chaos is not just spectacle. It is a map for what might come next in our exploration of the universe. Future missions like the proposed Io Volcano Observer aim to orbit and study this moon in detail, seeking to unravel its deepest secrets. The data gathered could reveal how similar processes might operate on exoplanets orbiting distant stars. Io's surface is not a fossil. It is a symphony of relentless change. And here is the real shock. This violence is not powered by radioactive decay the way Earth's volcanoes are. Instead, gravity is the maestro. The unending tidal tug-of-war with Jupiter and its moon siblings twists Io's insides, creating friction and heat that fuel eruptions found nowhere else in the solar system. The only similar process we know of is the tidal heating that keeps Saturn's moon Enceladus geologically alive, driving geysers of water ice. But on Io, the stakes and energies are far higher. Imagine what this does to our search for life. The same extremes that make Io so treacherous could, on other worlds, create the chemistry and warmth that living things need. On Earth, deep-sea hydrothermal vents teem with life, despite the absence of sunlight, proof that energy can come from within, not just from above. If tidal heating can sustain volcanic activity for billions of years, as it does on Io, then the window for life to emerge on similar worlds may be much wider than we imagined. Io forces a radical rethinking of energy and habitability. On Earth, life feeds on sunlight, but Io is powered by tidal heating, energy squeezed from the relentless pull of Jupiter and neighboring moons. This means that even distant, frozen worlds could hide vast reservoirs of energy deep within, where sunlight never reaches. Imagine an icy moon orbiting a gas giant in another solar system, its surface cold and lifeless, but its interior warm and dynamic thanks to tidal forces. The possibility for life in such places is no longer science fiction. Thanks to Juno and other robotic explorers, we are glimpsing Io's hidden workings for the first time. These discoveries are rewriting the textbooks, not just for Jupiter's moons, but for the very fundamentals of planetary evolution, sources of energy, and the fragile boundaries of habitability. Every plume, every new image is a clue for those hunting for signs of life in places no one ever expected. Not all of Io's volcanoes are the same. Some hurl fountains of molten rock, while others seep exotic gases that paint the landscape in haunting colors. This variety suggests that alien moons and exoplanets may harbor even stranger volcanic terrains, each with its own unique possibilities and dangers. On Earth, the diversity of volcanic environments, from basaltic shield volcanoes in Hawaii to sulfuric fumaroles in Italy, supports a wide range of ecosystems. Io multiplies this diversity on a planetary scale. But Io's story is not finished. With every new mission, we move closer to its heart and to answers that could change the way we see our place in the cosmos. The next decade could see landers or orbiters peering into Io's active volcanoes, sampling its sulfur snow, and mapping its hidden magma chambers. Each new data point brings us closer to understanding not just Io, but the forces that shape planets everywhere. Studying Io is not just about a distant volcanic moon. It pushes science to question, to leap forward, and to imagine possibilities beyond our most daring theories. Io's extremes dare us to look farther, dig deeper, and always be ready for awe. Imagine the discoveries waiting on exoplanets with similar tidal dynamics, where the wild interplay of gravity, chemistry, and heat could create environments beyond our current dreams.
Io is not just an anomaly. It is a warning flare for every explorer and scientist peering into the dark. This tortured moon shatters our old ideas, forcing us to accept that the cosmos is wilder, more volatile, and far less predictable than we ever dared believe. Turning away from Io means clinging to the myth that worlds are simple, silent, or dead, when the truth is far more thrilling. The universe is alive with chaos and possibility.
Io is our cosmic wake-up call. It warns us that our ideas about where life can exist are far too limited. The universe does not just tolerate oddballs, it seems to create and favor them. If we cling to old rules, we risk missing wonders, wasting precious years, and overlooking worlds that could transform our understanding of everything. In the 20th century, the discovery of extremophiles, organisms that thrive in boiling acid or deep ice, expanded our notion of habitability. Io demands we expand it even further.
In the end, the choice is yours. Keep the universe small and safe, or let Io set your imagination on fire. Because sometimes, the worlds that should not exist are the very ones that reveal how much more is out there, just beyond the limits of what we know. With every relentless eruption, every pulse from its boiling heart, Io demands we ask harder questions. What hidden energies might smolder within distant planets? How many other impossible worlds are waiting, ready to turn our textbooks upside down? Each plume of sulfur, each river of glowing lava, is a cosmic signal, an invitation to question the rules we thought were set in stone. If we let Io change us, we start to see the universe as a place of explosive potential, not just for wild geology, but maybe even for life in the most unlikely corners. Curiosity is our key. If we follow Io's lead and embrace the unknown, we could unlock discoveries powerful enough to transform science, exploration, and our sense of who we are in this vast expanse. The lessons from Io are as practical as they are profound. For planetary scientists, Io is a case study in how to search for hidden energy sources on exoplanets. For engineers, the challenge of designing spacecraft that can survive Io's radiation and heat offers a proving ground for new technologies. And for anyone who ever wondered if life could exist elsewhere, Io is a constant reminder. Never assume, always explore.